right, so I'm going to briefly go over our notes that we missed yesterday in our class because we did have a interruption. Mr. Padilla came to help. Okay, so we did that already. All right. So again, significant figures are the digits considered reliable as a result of measurement or calculation. Okay, it allows us to know how accurate our measurement is based on the specific tool we're using. Okay, so during our lab, you will have the graduated cylinder, but then you will also be using a ruler to measure the actual actual volume of the liquid inside of your graduated cylinder. And you're going to see that your calculations and the actual RAN measurements are going to be a little bit more accurate because you're able to get those decimal points that you're not able to get from the graduated cylinder itself. Okay, but it should still be about the same amount um, when you start to calculate it. Okay, all digits that are not zero are significant. So 1 through 9, if you see it in a number, it is already significant. Zero is significant when it is between two non-zeros. So like that 2002, those two zeros are relevant, important, accurate. And then when it is in a decimal point after the decimal point, it is considered significant. It is not significant when it is used to fix a decimal point, meaning it's at the beginning of a decimal point. You're putting 0 point something, then it is not significant in that 0 point, blah, 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 blah. Okay, but after the decimal point is significant. And then number 2, it is not significant when it's used at the end of a number, like a very grand number, 2,000, 5,000. You don't need all those zeros. Like you can still communicate effectively the amount with other ways instead of using all those zeros. Okay, so you can use 2K, 5K, etc. All right, so the metric system, this is what we weren't able to actually get to. The metric system, also known as the SI system, is the unit standard for most of the world. We're going to use it in class, and you use it in most STEM careers. You're going to use it as an engineer, as a doctor, but the metric system is what is most common, especially when you get into college, okay? So hold on, how do I hide that? All right, so I'll give you a moment to screenshot this. You can pause the video and screenshot it, okay? But this will just, add that to your notebook. In case you forget how to convert things, you can just use this procedure. But the way we're going to do it, because we only have one conversion from the U.S. customary system to the SI system, which is this 1 inch equals 2.54 centimeters. So if I give you 5 inches and I want you to convert it to centimeters, you are then going to, all right, so sorry. So we go from 5 inches to centimeters. I'm going to multiply 5 by 2.54. So in my calculator, I get 5 times 2.54. I get 12.7. And then you do the same thing with 10 inches to centimeters. 10 times 2.54, 25.4. Okay? And then the last one, 23 times 2.54, 58.42. Okay, and that is the only US to metric system conversion that we are going to use in this course. So here, take a moment to screenshot this. But this is a valuable tool because we are going to be using the metric system a lot, but you do need to know how to convert within the metric system. Thankfully, it is in units of 10 all the time. So when you're getting bigger, you're going to multiply by by more zeros, I guess. So kilometers to meters. Oh, where's my mouse? All right, kilometers to meters, we're going to multiply by 100. Meters to centimeters, we're going to multiply by 100. Sorry, I said 100. Kilometers to meters, we're going to multiply by 1,000. Meters to centimeters by 100. Centimeters to millimeters by 10. Okay, so if we're going to big to little, we're going to be multiplying, because if you have a big thing and you're trying to convert it to something small, you're going to need more of those small things to make up that big thing. Okay, but when we're going from millimeters to centimeters, we're dividing by 10. Centimeters to meters, dividing by 100, and meters to kilometers, we're dividing by 1,000. Because the idea is, if you need, if you're going from small to the big number, it's going to be a really small increment of that final big number, that big unit. Okay. So when you're going big to little, you need more to make up that big unit. When you're going from little to big, it's going to be very small compared to the big unit. You may get a decimal point for the most part when you go from millimeters to kilometers. Okay. And that was the rest of those notes. We did extra problems. Clear that. We did extra problems to practice. So I will go through those slides so you can practice it. Convert 100 millimeters to centimeters. Take a moment to pause. And then, so when you're solving that, you're going from millimeters. Let me get my pen. From millimeters to centimeters. So you're going to divide 100 by 10. If you put that in your calculator, you get 10. Okay. I also did share a trick. Depending on what you're dividing or multiplying by, is what you can do with the zeros involved or the decimal place. Okay. So if I have 100 and I'm dividing by 10, there's like an imaginary decimal point here, right? And I can move my decimal place over one spot. If I was dividing by 100, there's two zeros in 100, so I'm going to move it over by two spots. Okay? But overall, the answer for this one is 10 centimeters. Okay? Oh, cleared my screen. Eraser. Okay? And then I'll give you another moment to solve for this one, 978 millimeters to centimeters. And again, you're going to go millimeters divided by 10. You put that in their calculator, you're going to get 97.8. And again, if you don't want to use a calculator, you put an imaginary decimal point there and you move it over one place because you divided by 10, which has one zero.